All right, I'm going to show you how to do a two-dimensional momentum problem. And in a two-dimensional momentum problem, we need to have conservation of momentum in both the x direction and in the y direction. So what I've done here is I've added the masses and velocities to this picture. So mass 1 is originally traveling to the right at 3.2 meters per second, and it has a mass of 0.17 kilograms. And it hits this black ball, M2. The black ball goes up at an angle of 10 degrees and with a velocity of 1.5 meters per second. And it has a mass of 0.21 kilograms. And the ball itself, this one that I'm highlighting purple, goes downwards at some unknown angle at some unknown velocity. And of course, it still has the same mass of 0.17 kilograms. So what I've done is I have created two triangles here to relate the velocity v1 or v2 to the components. If you don't remember how to do that, go ahead and take a look back earlier in the semester when we talked about finding those components. But just as a reference, in the x direction, it'll be equal to velocity 1 times cosine theta and velocity 1 times sine theta. And then for v2, it would be v2 in the y direction would be equal to v2 times sine of 10 degrees and v2 times cosine of 10 degrees. And that'll be important in a little bit. The next thing I did is I drew momentum bar charts for both the x and y directions. So let's look at the x direction first. So in the x direction, we only had the first ball moving to the right to begin with. The other ball was at rest. And then once it hit, one of them went up and the other went down, both of them moving to the left, which I consider the positive direction. And so those are why both of these are positive. And so I get an equation these of momentum is mass times velocity. So mass 1 times velocity 1 in the x direction to begin with. That's why I have the little 0. That's to show that it was the starting velocity. And then mass 1 times the velocity of the first one in the x direction at the end, plus mass 2 times velocity, because momentum is mass times velocity, in the x direction after the collision, so final. So now what I'm going to do is instead of v1 x naught and v1 x final and v2 x final, I'm going to put them in terms of v1 and v2. And when I look at the starting velocity of v1, at the beginning it's all in the x direction, so I just left it as v1 naught to show that it was the starting velocity in the x direction, or the starting velocity in total. And then this is v1 x final, and we have v2 x final. So these are just going from here to there. So it's the only thing that's changing. And then my next step is to put in the numbers. All right, so I put in the mass of 0.17. I put in the starting velocities and the angles. So mass 1 is 0.17. Mass 2 is 0.21. And then I don't know V1 or my angle at the end. I do know my starting velocity at the beginning was 3.2. After the collision, V2 is going to have a velocity of 1.5 at an angle of 10 degrees. All right, so then I just need to take this and type some stuff into the calculator. And then I can simplify this by moving the 0.3102 to the other side. All right, so at this point, I recognize that I have an equation with two unknowns. I don't know my final velocity for V1, and I don't know my final angle. So what I'm going to do now is I'm going to switch to the y direction, and I'm going to see what I can do. So in the y direction, I did not have any starting velocity in the y direction, so that's why both of these are 0, because I started with a y velocity of 0. And then in the y direction, one of these balls went up and the other one went down. And it doesn't really matter which one I say is positive or negative, but one of these is going to have to be subtracted from the other one. So I just went ahead and put in that minus, because what I'm going to do is then I'm just going to add it to the other side. All right, perfect. So wouldn't matter which one I made negative, because at this point they're just equal to each other. And then what I'm going to do is I'm going to substitute in the signs, because V2 in the y direction is V2 times sine of 10. And V1y final is going to be V1 times sine of theta. And now I'm just going to plug in the numbers I already know. All right, so M2 is 0.21 kilograms. 1.5 is that final velocity for V2 times sine of 10 degrees, because it went up at 10 degrees. M1 is 0.17. V1 I don't know, and sine theta I don't know. So now I just need to multiply this into my calculator. So this on the left side will become 0.0547. And that'll be equal to 0.17 times the final velocity of V1 times sine theta. All right, so we're getting somewhere, but I still don't know V1 final and theta. But at this point, I have two equations and two unknowns, because over here I didn't know V1 final and cosine theta. So what I'm going to do is I'm going to take this, and I'm going to solve for V1 final. So I'm going to divide both sides by 0.17. And then I'm going to divide both sides by sine of theta. And at first glance, this doesn't look like it was helpful, but the reason why it was helpful is now I can take this and I can plug it in for V1 final. All right, so I'm going to plug in this 0.32176 divided by sine of theta for V1f. Multiply that times cosine of theta. All right, so now I have one variable. Unfortunately, this is still a little bit gross, because I have cosine divided by sine. And I told you guys you don't need to know what cosine over sine is. So one way to deal with this is I'm going to multiply both sides times sine of theta. I'm going to end up with 0.2338 times sine of theta. All right, now I've got a cosine on that side. I'm going to divide both sides by cosine now. And the reason why I'm doing that is because I noticed that I had a sine and a cosine, and I know that sine divided by cosine is equal to tangent. All right, so I substituted in sine over cosine for tangent. And so that's where this came from, is I took this sine over cosine and I turned it into a tangent. And then I just divided both sides by 0.2338. And I got 0.23396. Took the inverse tangent of both sides and got an angle of 13.168 degrees.
All right, so I went ahead and plugged in the numbers for the different angles and masses that were either given in the problem or that I had just solved for. Then I multiplied the 0.17 times what sine of 13.168 degrees is. And now I'm going to go ahead and divide both sides by that number. All right, and so I get 1.4 as the velocity of v1.